Thanks, everybody. So one thing that I wanted to, set the stage for here, I know you guys probably saw configurable modeling for maximizing business value. And in a data science crowd, we wonder, why does that matter? Well, if you don't have a focus on what you're going to try to accomplish, you don't necessarily know where your analytics is going in that case. So on my way here, there was a big thing that I was trying to understand. How do I get to San Francisco from Atlanta? And when you enter that into Google, you can walk, you can take transit, and you can drive. And if I chose to walk here from Atlanta, it actually says there's no walking directions available. I'm sure there are directions available, but it never came up. If I put transit, it takes 4 days, 14 minutes to get here from Atlanta. Both of those options felt a little unacceptable to me. And then when I'm thinking about driving, that option is also unacceptable because it would have taken me a day and a half straight through to get here nonstop. Okay. Now, so when I start thinking about that is, in this world of AI and the world of things being driverless, you still need an objective. And you still need to know what are the inputs to that. So in this case, that was all the information that I knew. Or I could drive to the airport and fly. That option was clearly the best, but the main point that I wanted to set the stage here for today as I go into the rest of the things I want to talk about is you need a destination and an understanding of available resources and approaches to be most successful in your journey. So just a little background, I work at Equifax. You may know us most for the credit file. What's interesting about that is, globally, our data captures over 820 million consumers, 91 million businesses, and over 7,000 employer contributions from data that comes from paychecks, pay stubs, income, and employment type of information. It's really probably one of the original big data companies. When we talk about data collection and the way that data has been coming together and being leveraged for decisioning, this started in 1899 as a company where you had individuals working for saving and loan companies and banks. There was two guys, Guy and Cater Wolford. They were brothers, and they lived in the Atlanta area. And they went around to all of the local savings and loans, had the data contributed to them, so that way they could help consumers get approved for loans quickly. So when you go in, and I'm assuming most of you have a mobile phone, right? When you go to get that mobile phone, there is a credit check that goes along with that. And if there was no credit check, you probably would be upset based on the fact that you didn't get your phone right away. So this was really an aspect of big data, this being pulled together and then leveraged. But how did all that information come together? It's not, in the academic world, data, it somehow magically exists. In a lot of these competitions, the data automatically seems to magically exist. However, there's much more to it than that. So what I want to think about here is when we talk about configurable insights, that's a kind of a buzzy sounding word, but configurable just means what are all the inputs you can take from both a data source, a methodology, and an output and an assessment metric that ties to your objective. So think about it like that. And then the advanced analytics are all the things that most of us focus on with respect to machine learning, all the various elements of predictiveness that you have at your disposal, including H2O is one of those key components that you can leverage. But then also the key driver behind a lot of that and the main ingredient is going to be the data. So one of the things that we have available is our Ignite platform. And what we talk about with our Ignite platform, it's a system, a database, a Hadoop infrastructure where we try to reduce friction across, say if you're going to search for data. Oftentimes when you think about that question, it takes a long time to go out and find the data that's relevant. For a lot of the problems that we help serve the market, we have that data already reposed, keyed, and linked and ready for use. And so what we try to do is remove the friction around, if it takes you several months to go find that data, we repose it in a Hadoop infrastructure. The second part is making it available to run quickly. And so what we've done, as an example, we make a lot of different software available. And one of those that we have available through our system, we leverage H2O. Some of our customers request that as a tool to leverage. But we also have others available from the market to help really drive the key component of how do you derive insights quickly and create models quickly with all the data that's there. And then the last area is how do we remove the friction on taking that information and putting it into a production environment. Now, in a system like this, where you think about all the banks that are out there, all the telecommunications companies, they're all running credit. They're all running some form of check, and we're all very impatient with the time it takes. So if you went, say, and you applied for a loan or a mobile phone, and it took longer than half a second, you'd probably be upset. So there's a lot of processing that needs to happen to go search for records, calculate those records, and then return in real time. So the implementation of these types of things, it's not trivial. In nature, there's some complicated component to being able to do that, specifically if you're running more complicated algorithms in production. So when I take it back, it's so easy to skip the step of understanding the question, understanding your objective, understanding the market. And so going back to the example that I used for how was I going to get to San Francisco, if I knew my objective was I don't care how long it takes, or I don't mind walking, then it could help set that path in a direction that I may not necessarily want to go. So in terms of understanding this, like there's a very clear objective. So one example that I'll use is in the fintech loan origination space. There's a lot of data available now. There's a new cropping up of the amount of companies that are starting to launch personal loans available online. And so what we need to do is understand, what does that market look like? What's the size look like? What are others decisioning in that space look like? What are some of the trends that can happen? And then knowing what are all the available data sources that are out there. There's in this case you could leverage credit data, or there's other alternative data sources. But what happens if there's a data source that would be leveraged that may not be legal? Because there's a lot of things that need to be incorporated into this. Where as of now, if you were declined for a loan because of a post you put on social media, that may not necessarily be fair. It may not be. It may not. And if that did happen, like how does someone tell you that? And then how do you respond and fix that type of information? So really, the first thing is to really understand the trends in the market, really understand the question, really understand the objective that you're trying to solve for, and then move that into building blocks. And then the last part, then, without skipping that most important first step, is of course the model development, and that's where the modeling AI with there's the picture of the H2O right there for you guys. So in terms of the various components, like in this case, we see online finance market trends. Now there's a lot of different data that I pulled together here. I'm not going to go into a lot of the details because it may not necessarily be relevant to this crowd. But in essence, the bars are representative by going back in time, to multiple years ago in the top, and shows the growth of that market by segment. So there's online finance. Now we may think online finance is the only thing that exists today. That's not true, because there's credit unions who've been offering live checks now. There's your traditional banks that you can go walk down the street to a bank here and get that same type of offering. And then it shows, well, what happens from what type of risk is going from each of those? How fast do they decision? How are they winning and competing in the market? So really knowing that problem makes it important to understand. And it's really also important to understand if you're running one of those businesses, what are the others in the competitive space? What are they doing? What data sources are they using? What information are they incorporating? That stuff is not just pre-canned and ready. It's not just made available like the competition data sources. You have to go out and find the data. You have to take that information and then call it into a usable format, to create your features, and then put that into your modeling software. One of the other things that we've done at Equifax is we've created a technology called NeuroDecision, and we've talked about explainable AI. This is, to my knowledge, is one of the first patents that has come out around explainable AI. And what it does, if you think about this space, and many of you already have familiarity with artificial neural networks, is that oftentimes as you move across the nodes, there's a level of non-monotonicity. And that non-monotonicity could create patterns and trends that are not business logical. So a great example is if you have filed bankruptcy, you can't file bankruptcy again for another 7 years. So if you just let the data model that, then it would actually come out as a positive thing if you filed bankruptcy. So you would actually receive the misdirection of points in a credit score, if that was true. And so what would happen then is if you got declined for credit, it could say, go file bankruptcy. And we know that that's not a valid explanation or behavior, and it wouldn't necessarily hold true for the model. But if you just let the model drive on its own, that could happen. But within this use case, we've created a constrained neural network that takes and forces monotonicity at each of the end node levels. So that way, when you get to the end of that model, there's an explainable component that comes directly out of the model that says this model is not only producing the reason for the point total or the direction that the neural network took it, but it's also business logical. It's from the standpoint that it makes sense that if you read it as a human and you interpreted what is this trying to tell me, it produces something logical that you can actually go back and take action on if you needed to. And then there's a video that we have available if anyone's interested in going to check it out. It's fairly high level. And there's of course, given that it was the patent was received in November, you can go read all the documentation around that as well. So just in terms of like some of the lift and things like that we've seen associated with this. So with we of course support all the various lending markets, and this is just example where when you think about the things we do, there's all the metrics you have around statistical performance or I guess predictive performance. How accurate are you? How much more lift do you have? But none of that matters unless you translate it into the original objective. And so in this case, the objective was for this particular example was how can we increase an approval rate, meaning more people have an opportunity to have an approval rate, but the bank wouldn't take on more risk associated with that. And so the predictive metric of where we were able to have a higher increase in that resulted in a 21% higher approval rate at the same I guess incremental bad rate. Of course, as you move across the curve, that would change, but that was where the maximum benefit occurred. And one of the things that we also included in that is you think about oftentimes data could be static, and when you incorporate additional information, this also incorporated various forms of trended data. And trended data is becoming more and more popular in this space, where you're not just looking at what happened now, but what's happened in the past, and how can you incorporate that data as well. So I think with any problem that we have, continually seeking out new data and seeking out new ways to accomplish that problem is a very key in terms of improvement. And so when we look at as an example, there's one measure that's leveraged in I guess in the credit scoring space is the KS statistics, is Kolmogorov-Smirnov, which the traditional use for that is to try to determine if two distributions are the same. But in this case, it's trying to maximize the separation of those distributions from a cumulative percent standpoint. And so the KS representation here, the example in the first bar is 50. What that means is that if you've defined those who are going to default on a loan versus those that are not going to, if you create that distribution, the maximum separation across those cumulative distribution curves would be 50%. So, and then as you incrementally move forward, it goes 50, 51, 54. So the maximum of that number, the possible maximum is 100. But of course, that's theoretically impossible. So to receive, unless you'd have a perfect model and you wouldn't need a model. But so as you look to do the comparison, the baseline model was a model that was already in existence, and so that's one that is continually leveraged. And what happens if you incorporate some trended data? So what it shows is that when you incorporate trended data in this particular perspective, the blue bar represents what are the features coming from trended data. And then it starts weighing down the element and the information importance from the non-trended data. And the same thing increments as you move forward. So the more trended data would be TD84 in the third column. And in the last column is a representation of incorporating the NeuroDecision neural network technology along with the 84 months worth of trended data. So you can see that the predictiveness continually increases, and even when you increase the more data, methodology actually can help get more predictive as well. So there's really a nice combination of those two that become important. So then, when we think about that, there's oftentimes when you hear the word credit score, like we oftentimes think about the generic credit score that exists in the market. But in actuality, there are so many credit scores. Almost every bank leverages their own. They have a score that they've created on their own consumers because it's more specific. And so say, for example, if you're going to apply for an auto loan, when you go to apply for that auto loan, the way that you would pay your auto loan, given that is an installment payment, you typically pay month over month the same amount, it's going to be very different than the way you may pay a credit card, for example. And so what happens is you can have a generic score that would try to be a one-size-fits-all, and some still do that. So some will leverage standard off-the-shelf scores that exist. You may have heard of FICO or Vantage Score that are out in the market as market scores, but you can also create a custom model. And in the custom model case, that's where you get into the whole complicated data science perspective, where let's look at all of our data sources, let's look at what attributes exist, and then as you move forward, there's all the sample design, all the traditional data science elements that you try to do when you create some form of model that is static and that is put in place to be leveraged. And that oftentimes in this space can take months, to actually generate and create. So you have an off-the-shelf score that's not as predictive, and then you have a model that takes months, and it's going to be fairly predictive, but it may not necessarily maximize the benefit that you have of time and speed. So when we look at that, there's the traditional way where we have you of course have to define what is my objective, which is your target. You create the sample. You go out and understand through that sample design what data sources are available. Am I looking to expand my market footprint? Say if I've only operated my business in the Southeast, maybe I want to expand nationally. How do we incorporate that information further? And then there's various ways that you can do segmentation. There's model development, and in this case, we can talk about NeuroDecision. There's assessment, but the challenge behind that is that that's one time. So say if I put this into, you can enter all these parameters into some driverless AI. You can say here's my target definition, here's the sample that I've selected, and here's the data sources. Go run model. Run model a billion times, as many times as we want to run that. But how did you know that you selected the right things? So really, this is where your mind comes in as the one who helps to set that guide. So as an example, I've just built this out just illustratively to show the many possibilities that you can have. So even within a target, in this space, there's you could set a target for did this entity pay the loan 30 days past due, 60 days past due, 90 days past due, to really try to hone in on different levels of predictive performance. And then from your sample design is, do you want to look at your own population of through-the-door applicants, or are you looking to expand or contract your footprint? Have you had a tighter credit criteria before, which you'd have to do more extrapolation, and through that extrapolation you have to have some form of inference. And then the available data sources. There's so many data sources that are available in this space. There's credit data. There's an analogous database on your mobile phone and how you pay your like pay TV and satellite, for example. There's data sources on public record and things like your liens and judgments and things like that could potentially be leveraged for this. There's data sources on have you accessed a payday loan, because many of those don't report to traditional credit reporting agencies. And so how do we both maximize the benefit of things like that? Say if you've been paying that, you should get benefit for that. And so how do we incorporate that type of thinking into the model? And then of course, there's a variety of built-in segmentation. I already mentioned the example of bankruptcy, as an example that if you build a separate model for that segment, then you don't have the problem that I talked about with respect to getting pushed down the wrong path because of a behavior that you might have had. And then there's other components you can incorporate, like was that profile thin or thick or clean or dirty from a credit perspective. And then from a modeling standpoint, there's of course in this space, logistic regression was oftentimes it was the de facto for the last 50 years or so, because it was explainable. And now given I was talking about the explainable artificial intelligence and NeuroDecision technology that we've been able to work on, we can do a little bit more in this space. Mainly because the explainability and business logic it trumps predictiveness in all these cases. From the standpoint that you can't just necessarily have the model produce things that are that are not logical. Then of course from an assessment standpoint, this is where the assessment has to tie to your target in some way. And so you can do was predictive power important, and with data sources, a lot of times we think about coverage and scorable rate like that. Oftentimes we can very easily overlook that, and when you're just approaching something from an academic exercise, where coverage, predictiveness, and uniqueness are so important when you're looking at various data sources, because you don't want, in this space, like data is not cheap either. Like in a lot of the competitions that we go look at, it's cheap. You get data for free, you run the model, and then you produce something. But in the real world, data's not free. You have to go buy the data, and you have to find ways to hone in on that information to create that. So you actually get a diminishing return if you go try to obtain every single data source. So you want to maximize your resources to be able to identify and select the right information, the right data sources for the prediction. And so as an example, when we think about that, this is one example possibility. But as you consider those pre-programmed possibilities, the predictive element is really it's a permutation of all these different components where you could do various targets, different sample design, different data sources, segmentation, et cetera. And this is where, when you create your parameters for then the driverless analytics to occur, this is where you can actually maximize your benefit of the problem you're trying to solve. Because you create your parameters and you really know and understand what's going on and then can assess that back to the problem at hand. So as an example, when we talk about the configurable model, we ran through, in this case, we were working with this was, an online financer for, for retail furniture. And what we did is we incorporated that prior page, ran data through multiple different targets, multiple sample design, and multiple data sources. And in today's world, with all the parallelized analytics up front, you can create, you can do that before, like back in, many of you are doing data science before a lot of the parallelized systems were available. It was almost like you had to measure 15 times and cut once. And you only had one opportunity to create that design, because when you went to go get these data sources, it would take us weeks, months to actually go obtain the data, and then you'd have to sit, and then if you made a mistake, you're like, oh dang, I got to go back and wait another several weeks or months to just go get the data. And now, given that it's more available, all keyed in linked, like I referred to, you can actually measure and cut and identify how do we better model appropriately. And so in this case, the lift was 16%. We talked about KS before, 16% lift in KS over a custom model. And then the example on the right is the configured score. It had an 8% increase in scoreable by identifying new data sources. Okay. And so when we look at that example, you can see the incremental benefit was incorporating, there was data sources, optimal segmentation, and then methodology. So we should, the key here is don't lose sight of your target. Don't lose sight of what you're trying to accomplish. And remember that the predictive part is only one part. And then lastly, we talked about in this space, implementation it's quite a hog. And I talk about on the left-hand side the legacy approach. Years ago, 6 to 9 months to, if you created something new for this space, you had to code it, you had to get it right, and it had to exist. In the new world, through this example, even if you create code and have that code ported into another system, it can still take up to 30 days because you have to make sure it's right. If that model is wrong, then or it's not been measured appropriately, then many people will be out of, you may not get approved for a mobile phone. So there's so much information and corrective behavior that needs to be incorporated into this. So I guess the thought that I'd like to leave you with is, as you're doing your modeling, don't forget about all of the things that you started with. Don't forget the target that you're trying to go after, the objective. Don't forget that there's multiple, we talked about the data sources are in your hands. Don't just think the data is going to come to you, because that's not how the real world operates. You'll have to think about the data, and you have to go seek out other data and processes, and then you run it through your driverless systems. So with that, I guess we're about out of time. So any questions?
Thank you so much, Tom. There are a couple of questions, but if you want to take one question. We're out of time, but just take one of them.
So the benefits hazards of generating credit scores based on your particular enterprise population. When you have your enterprise population, the main benefit of that is you're closest to what people will come in through the door in the future, because more often than not, a customer of, say, Bank of America, they would be the same as they were before. Wells Fargo, they'd be the same as they were before. But if you leverage additional data, then you can expand or contract from that. So say if they're trying to expand their footprint, then they'd be able to do that. So, okay.
Thank you.
Thank you.
Thank you for sharing your use case. Thank you so much.
Thanks.
Yeah, thank you.